Have you ever wondered what it would feel like to stand beneath a red sun, on a world locked forever between perpetual day and endless night? A planet orbiting a star so faint, you could mistake it for an ember fading in the dark. Yet it may hold answers to one of humanity's oldest questions. Are we alone? Today, we embark on a journey across 40 light-years of cosmic ocean, to a planetary system that has captured the imagination of astronomers, dreamers, and storytellers alike. A system unlike any other ever discovered. Its name, TRAPPIST-1. And among its 7 Earth-sized worlds, there is one that stands out, TRAPPIST-1F. This is not just the story of a distant planet. It is the story of how humanity seeks its reflection in the stars, and what TRAPPIST-1F might one day reveal about life beyond Earth. The year was 2016. A team of astronomers using the TRAPPIST telescope in Chile announced something extraordinary. They had detected planets orbiting an ultra-cool red dwarf star in the constellation Aquarius. This faint star, invisible to the naked eye, became the stage for one of the most profound discoveries in modern astronomy. At first, 3 planets were revealed, but by 2017, with the help of NASA's Spitzer Space Telescope, astronomers confirmed the existence of 7 Earth-sized worlds, all orbiting this single dim star. The discovery was so breathtaking that it made headlines across the globe. Here, for the first time, was a compact planetary system that looked like a miniature version of our own solar system. And nestled among those 7 worlds was TRAPPIST-1F. TRAPPIST-1F is a planet slightly larger than Earth, with a radius about 1,045 times that of our planet. Its mass is estimated to be around 70% of Earth's, making it a rocky world, not a gas giant. It orbits its star at a distance that places it within the habitable zone, the region where liquid water could, in theory, exist. But what makes TRAPPIST-1F so fascinating is not just its size or its orbit, it's the conditions it might host. The star it orbits is an ultra-cool dwarf, far smaller and dimmer than our sun. That means TRAPPIST-1F receives far less energy, far less heat. Yet because the planet lies closer to its star than Mercury lies to the sun, it manages to sit in that delicate balance. Not too hot, not too cold. Imagine standing on TRAPPIST-1F. The sky above is dim, tinted with a faint reddish glow. The star, larger in the sky than our sun appears from Earth, burns with a deep crimson hue. And if you looked up at the horizon, you might see the silhouettes of other planets, siblings orbiting the same star, hanging in the sky like moons. One of the most remarkable features of the TRAPPIST-1 system is its resonant orbit. Each of the 7 planets is locked in a kind of cosmic rhythm, orbiting their star in harmony, much like dancers moving to the same beat. TRAPPIST-1F completes an orbit around its star in just 9.2 Earth days. That means a year on TRAPPIST-1F lasts little more than a week here on Earth. But because of the star's faintness, this tight orbit does not scorch the planet. Instead, it places it within reach of habitability. It is also highly likely that TRAPPIST-1F is tidally locked, meaning one side always faces its star, bathed in eternal daylight, while the other is cloaked in endless night. If so, the most habitable regions may exist in the twilight zone, the thin strip between day and night where temperatures are more moderate. This is a world of extremes, a world of contrasts, a world unlike any we've ever known. Perhaps the greatest mystery of TRAPPIST-1F lies in its atmosphere, or lack thereof. Without an atmosphere, the planet would be a barren rock, exposed to the harsh radiation of its star. But with the right kind of atmosphere, TRAPPIST-1F could be a cradle for life. Scientists have proposed many scenarios. Perhaps TRAPPIST-1F has a thick atmosphere, rich in carbon dioxide, trapping heat like Venus but in a more delicate balance. Or maybe it holds a nitrogen-rich sky, more like Earth's. In either case, an atmosphere could allow liquid water to exist, on the surface or below layers of ice. Recent studies using the James Webb Space Telescope are beginning to test these possibilities. By analyzing the light that passes through TRAPPIST-1F's atmosphere as it transits its star, astronomers hope to detect gases like water vapor, methane, or even oxygen, the chemical whispers of habitability. So far, the results are tantalizing but inconclusive. We stand at the threshold of discovery, waiting for clearer answers. This is the question that lingers in every conversation about TRAPPIST-1F. Could life survive here? The challenges are immense. Red dwarf stars like TRAPPIST-1 are known for their stellar flares, powerful eruptions of radiation that can strip away atmospheres and sterilize worlds. For TRAPPIST-1F, survival depends on whether it has magnetic fields strong enough to shield its surface. But where there are challenges, there is also resilience. Life on Earth has survived in the harshest conditions, from boiling hydrothermal vents to frozen Antarctic deserts. If life can emerge here, why not on TRAPPIST-1F? Perhaps beneath its surface, oceans could remain liquid, heated by geothermal activity. Perhaps microbial life has adapted to the dim red light of its sun. Or perhaps TRAPPIST-1F holds the seeds of evolution that could one day flourish into complexity. For humanity, TRAPPIST-1F is more than a planet. It is a mirror for our hopes and dreams. It reminds us that Earth is not unique, that worlds like ours may exist across the galaxy, waiting to be found. It inspires novels, films, and artwork that imagine what it would be like to walk on its alien surface. In a way, TRAPPIST-1F has already become part of our cultural heritage. Proof that the search for other worlds is not just about science, but about our deep collective longing for connection. The journey to TRAPPIST-1F will not be easy. At 40 light-years away, even our fastest spacecraft would take hundreds of thousands of years to arrive. Yet the study of TRAPPIST-1F does not require us to go there, at least not yet. With the James Webb Space Telescope, with future observatories like the extremely large telescope in Chile, and with ambitious missions yet to be imagined, we are learning to read the light of distant worlds as if it were a book written across the stars. One day, perhaps, robotic probes propelled by solar sails could reach the TRAPPIST system. One day, perhaps, humanity itself could follow. And when that day comes, the first human to set foot on TRAPPIST-1F may look back at the faint red glow of its sun and realize, we are no longer bound to Earth. We are wanderers of the galaxy. So, what is TRAPPIST-1F? It is a planet, yes. A rocky world orbiting a dim red star. But it is also a symbol of discovery, of curiosity, of our refusal to accept that Earth is the only story worth telling. Perhaps TRAPPIST-1F is lifeless, a barren rock spinning in silence. Or perhaps, beneath its crimson skies, something stirs, something waiting to be found. And that is why we keep looking. Because in every world like TRAPPIST-1F, we glimpse the possibility that we are not alone. And in searching for them, we may discover not only life beyond Earth, but a deeper understanding of what it means to be human.